All right, students, today we are going to talk about writing and solving a system of linear equations. And on your paper, I want you to find the problem that is about the sheep and the geese. You should have folded your paper like a booklet, and this may be on one of the sides, or it should be on one of the sides. So first, let's read the problem. It says a farm has only sheep and geese. It has a total of 58 animals and a total of 180 legs on the animals, and we want to determine how many sheep and geese are on the farm. So one thing that we want to notice is that we are going to set up two different equations. One equation is going to be about the animals, and the other equation is going to be about the legs on the animals. So the only information so far that we're given in our problem is that we know that there are a total of 58 animals. So if I go to this first equation that's about the animals, then I can go ahead and put this total down from the 58 because I know that's what this number is going to represent. So let's go ahead and write that in, a total of 58 animals. We also know from the information provided that on those animals, they have legs. So there's a total of 180 legs. And our second equation is going to be about the legs. So we can go ahead and write that down for our total as well. So if we want to determine what information goes here in these blanks, then first or second, we want to look at what our variables represent. So in this problem, you are actually given the variables. We have S, which represent the number of sheep, and then we have G, which represent the number of geese. So in our first equation, that represents the total animals, we're trying to figure out how many sheep and we're trying to figure out how many geese, but since we are not sure the exact number, then we have to use variables. So number of sheep will be represented by the letter S. So we can go ahead and we can write in the letter S. And then number of geese will be represented by the letter G. So I can write in the letter G. So my first equation is going to be S plus G equals 58. Now my second equation is going to require some thinking from us because now we're talking about the legs. So we have to think about, well, how many legs does each sheep have? And how many legs does each geese have? Or does a goose have? So if you look at the image here, a sheep has 4 legs. So then we can write down 4 times S because it's going to be 4 legs for every sheep plus, well, a goose, or each goose has 2 legs. So then we can write down 2 times G, and that's going to give us the number of legs total from all the geese. And so now this is our system of equations. We have 2 equations. The first equation is represented by the animals, and the second equation is represented by the number of the animal legs. And so now we can go ahead and look at the part of the question which we can figure out, well, how many geese and how many sheep are there? Because this is what we would like to answer this question here. And we can use this system to answer the question by graphing it and seeing, well, is there a solution? Will these 2 equations intersect? Or is it going to be parallel? Or is it going to be a line is it going to be the same line? So those are the things that we're checking for. Before we actually graph this in the calculator, since we can only have the variables x and y, I want to take this equation and I want to convert it into in terms of x and y. And so this part doesn't necessarily matter, that how we choose to label x and y, but I am going to label the sheep as my x since that's listed first, and I'm going to label my geese as my y since that is listed second. So then when I go to rewrite my equation, well, my first equation, instead of it being S plus G, I'm going to change that to x plus y and then equals 58. That part does not need to change. And then in my second equation, instead of it being 4s plus 2g, well, my second equation is going to change to 4x plus 2y, and that's equal to 180. And so now I can take this system and we can type this in our calculator and we can see if there is a solution, and then we can find that solution. So we're actually going to do that part together. So now we can focus on finding the solution to our system. And to do that, we know that we need to graph it like we've done for the past couple of days. So go home and then number 1 for new document. If it asks you to save, no, you don't want to save it. And we're going to add a graph. Remember, we have to delete the equal sign and we want to select number 6 for relation. And we're going to type in our equation, but we're going to type in the equation that we changed in terms of x and y. So the first equation was x plus y equals 58. Hit enter. Now notice nothing showed up, and that's okay. That's because we have, if I go back here, we have the number 58, and so that's just out of the viewing range. So I'm going to have you zoom here so we can see that first equation before we type in the second equation. So to zoom, we're going to hit menu, and then we're going to hit number 4 for window zoom, and then number 4 again for zoom out. And your magnifying glass should already be in the center. And I just want you to keep clicking until you see the line cross the y-axis and the x-axis. And once you see that, you're good. You don't have to zoom anymore. And now we can type in our second equation. So hit tab to bring back up the box. And we want to type in our second equation, so relation number 2. And that second equation is 4x plus 2y, and that was equal to 180. Hit enter, and now we have our first equation in blue, our second equation in red, and we can see that they do intersect, which means there is one solution. And so now we can find that one solution. Hopefully you remember how to find that one solution from the practice you had yesterday. So hit menu, and we would like to analyze the graph, number 6, and then we would like to go to the intersection here. So number 4, number 6, and then number 4. And remember, you can click anywhere on the left side of that intersection. So I can click all the way over here, or I can click up here. So I'm going to click here, and I'm going to slide my line across until I see the words intersect. And this is my solution, 32 and 26. And so what that point tells me, if I go back to my problem here, so I write down the ordered pair 32 and 26, I know that my X represents the number of sheep. So this number is like my S, and my Y represents my number of geese. So if we want to write that down as a sentence, we can just simply state there are 32 sheep and 26 geese on the farm. And that will be sufficient enough to answer that question. And if you wanted to actually check it algebraically to see if that solution is correct, just take the 32, replace it with X, and take the 26, replace it with Y. You should get 58. And in this equation, replace the X with 32 and the Y with 26, and then you should get 180. So that's what it means for this ordered pair to be a solution. It's the only point that makes both equation number 1 and both equation number 2 a true statement. If you have any questions, please ask. That's what we're here for. Feel free to rewatch the video or simply just ask for help. Thank you.